All right, so this is going to be a quick review on z-scores. I'm going to do one of each type of problem just as a refresher about what we talked about yesterday, and then you can work on the assignment. So you only need to watch this if you need extra explanation. So here we go. Remember, the z-score is going to refer to any value that is less than. So it's always shaded to the left of the curve. So the formula for the z-score is x minus mu over sigma. I'm going to start with question 2 first. So it says a 5th grader takes a standard achievement test. The average is 125 and the standard deviation is 15. This person scores a 162.5. So let's just figure out first what this looks like. The average is at 125 and the standard deviation is 15. So 125 plus 15. So this would be 140. This would be 155. So this person scored very high and very above average. So this person scored a 162. So if we visually look where that is, it is here. Okay, so it says what percentage of 5th graders scored less than this person? So since this person scored very high, there should be a very high percentage of people who scored lower than her, right? If you get the highest grade in the class, then everybody else is lower than you. So let's figure out what the percentage is. So here we go. We're going to get the z-score. The question is about 162.5. The average is 125. The standard deviation is 15. So I put this in my calculator. 162.5 minus 125 is 37.5 divided by 15 is 2.5. Remember, that's not the answer. You need to go to your table, and I'm looking for positive 2.5. So here's 2.5, and it's 2.50. So 0.99379. Which tells you that about 99.379% of students scored lower than this student, which makes sense based on what we just talked about. Okay? If it's greater than, remember you have to do more work. You have to do one more step. So the average score on this person's SAT was 500. The standard deviation was 100. So 600, 700, 400, 300. What is the probability that a student scores higher than a 430 on the test? So 430 would be about here. So it should be a little bit more, I would say, than half of the people should score more than 450 or 430. So 430, that's what the question is asking, minus the average over the standard deviation. 430 minus 500 is obviously negative 70 divided by 100 is negative 0.7. That is my z-score. I'm going to the table. It's negative 0.70. So negative 0.70 is here. 0.24196. 0.24196. So what that is telling you is that 24.196% of people score less than a 430, which makes sense. Not that many people are getting that low of a score on the SAT. So what percent would be scoring higher than 430? Well, the whole curve is 100%. So this is the extra step you have to do because it is more than minus 24.196. And you get 75.804%. So if it's greater than, higher than, more than, whatever, you have to do one more step. And then the last case scenario is in between. So for this one, the average is 22.8. The standard deviation is 1.1. So if I'm just making my axis here, this would be 23.9, 25, 26.1, and then I'm going the other way. So this would be 21.7, 20.6, 19.5. So I want to know what percent of people are in between 20.1, so that would be about here, and 23.1, which is about here. So you're looking for all of this area. So you're going to do two problems. You're going to do first 20, it doesn't matter. Let's just do 23.1 minus the average over the standard deviation. And then you're also going to do 20.1 minus the average over the standard deviation. So this winds up being 0.272, so 0.273, and then 20.1, 22.8, and this winds up being negative 2.45. So let me get these two values. Negative 2.45. Let's get that one first. Negative 2.4 and then 5. 0.00714. 0.273, it's positive, so 0.2 and then 7 is here, 0.60642. And so now you want the area that is in between these two. So what's 0.60642 minus 0.00714? You get 0.59928, or about 59.928%, which kind of makes sense because it looks like almost half of the graph is shaded in. So about 59.928. So hopefully if you were a little bit lost yesterday, I know this was like kind of a crazy lesson here. Hopefully that clarified and cleared up some things.